In this video, we will look at two examples where we find the distance traveled based on the velocity. Since both position and velocity are functions of time, we will write position as s of t and velocity as v of t. And we know that the velocity is the derivative of position. We also just found that the change of position from t equals a to t equals b equals the area under the graph of v of t, our velocity, from t equals a to t equals b. Let's now look at our example. Suppose that a car's velocity, given in feet per second, is v of t equals 5t. How far does the car travel in the first 10 seconds? To find the solution to our question, let's first dissect what the question is asking. The phrase, how far does the car travel, is talking about our position, s of t. In particular, it is asking what is the change of s of t. The phrase, the first 10 seconds, means that we are talking about the time interval from t equals 0 to t equals 10. So we want to find the change of s of t from t equals 0 to t equals 10. But we know that this equals the area under the graph of v of t from t equals 0 to t equals 10. So let's look at the graph of v of t. Since v of t equals 5t, its graph is a line, and what we are looking for is the area under the graph from t equals 0 to t equals 10. To compute this area, we'll use that the area of a triangle is given by 1/2 base times height, since this is a triangle. The base of this triangle is length 10, so we have b equals 10. And the height of this triangle is given by the height of our graph, which is v of 10, or 50. So h equals 50, which tells us that the area of the triangle is 1/2 times 10 times 50, which is 250. Bringing this back to our original question of how far the car has traveled, we have that the change of s of t from t equals 0 to t equals 10 equals the area under the graph of v of t from t equals 0 to t equals 10, which we now know is 250. So our conclusion is that the car travels 250 feet in the first 10 seconds. In our second example, we'll assume that our car's velocity again is given in feet per second, but this time it is given by the function v of t equals 5t plus 10. Notice here that our starting velocity, v at 0, is 10, unlike our last example where our starting velocity, v of 0, was 0. Again, we want to ask the question, how far does the car travel in the first 10 seconds? Similar to our last example, we can translate the question from how far does the car travel in the first 10 seconds to what is the change of s of t from t equals 0 to t equals 10. Again, to solve this, we'll use that this equals the area under the graph of v of t from t equals 0 to t equals 10. So again, we need to look at the graph of v of t. Like last time, v of t is a line, but what is different here is that v of t does not pass through the origin. So when we are looking for the area under the curve, we do not just have a triangle. So what we will do is break our area up into two regions, a triangle and a rectangle. And to compute the area under the graph, we need to compute the area of the triangle plus the area of the rectangle. Like last time, to compute the area of the triangle, we will use that the area is 1/2 base times height. Once again, our base is 10 and our height is 50 because it changes from a starting velocity of 10 to an ending velocity of 60. So the area of the triangle again is 1/2 times 10 times 50, which is 250. Now computing the area of the rectangle, we have that the height is 10, and again the base is 10. So the area of the rectangle is 10 times 10, or 100. Now putting this together, we have that the area under the graph of v of t is 250 plus 100, which is 350. Bringing this back to our original question, we have that the change of s of t from t equals 0 to t equals 10 is the area under the graph of v of t from t equals 0 to t equals 10, which we now know is 350. So we can conclude that the car travels 350 feet in the first 10 seconds.